Alright, so welcome to lecture 2. So we're going to be starting this lecture with a short review on plotting points on a Cartesian coordinate system, or on a Cartesian plane. So I'm going to draw up the plane here. So we normally have our x and y axes. And then on the x-axis, on the right-hand side, these are positive numbers. On the y-axis, on the top, they're positive. And then on the y-axis on the bottom, they're negative. And then, of course, on the left-hand side of the x-axis, these numbers are also negative. And so on. So when we plot points, the points are normally written inside brackets. So we'll just do 1, 2. And what this is representing is we're going to move over, starting from the origin, we're going to move over 1 on the x-axis and then move up 2 on the y-axis. So this point would be, starting here, we'd move over to the right 1, up 2. This point is going to be right here. Now if we add a couple negative numbers, so like maybe -3 and -1. Anytime it's negative, we're going to go in the opposite direction. So starting off on the x-axis, -3, we're going to move over 3, and then -1, we're going to move down 1. So this point's going to be somewhere around here. And then we can mix and match. So 1, -2 would be over 1, down 2, -1, or 1, -2 would be right there. So yeah, that's the basics of it. If you haven't done this for a while, I would recommend just trying it by yourself for a couple times, but you should get the hang of it pretty quick. You're going to use this a lot in calculus, especially when visualizing functions and graphs, and what derivatives and integrals actually mean. You're going to be using the Cartesian coordinate system and points all the time. So really get good at this, otherwise calculus is going to be very hard. Okay, and then since we can plot points on this Cartesian plane, we can also plot graphs in much the same way. So let's say we have a function y equals x plus 2. So we can plot this on the graph by plugging in different values of y, or of x, and seeing what values of y result from it. So let's plug in x equals 0. Get 0 plus 2 is 2, so y is going to equal 2. We can plug in 1, so when x equals 1, 1 plus 2 is 3, y equals 3. We plug in -1. When x equals -1, y is going to equal 1. And so now we have a set of points we can draw on the plane. So we have 0, 2, it's 1 point, 1, 3, so 1 up 3. And then -1, 1. So -1, 1. So I'm going to use a different number, or a different color here. So we just graphed a line. If we connect these points, we get a line. Now, if we want to combine this topic with absolute values, which is what the purpose of the previous video was, we can get not just lines, but we can actually get planes here. So let's consider the equation, or the relation of x is less than 3. So I'm going to erase what we did here. I was going to combine it, but I realized let's just start out a little more simple. We'll combine it later with an actual function. But let's say we have this, x is less than 3. So when we want to graph this, let's first find where x equals 3. That's going to be here. Now the tricky part of this is no matter where on the y-axis we are, when x equals 3, it will always be in this same spot on the x-axis. So whether we have x equals 3 or x is less than 3, we're going to have to start here. And we want to start by actually drawing a line through x equals 3. Now consider each side of the line. If we were on the right-hand side of the line, all of these points, these hypothetical points that you choose, so it could be this one at x equals 4, y equals 1. It could be x equals 5, y equals 4. All these values are going to have x greater than 3. So when we consider this x is less than 3, any point on this side will solve or will make this relation true. So by graphing x is less than 3 on a graph, we are actually graphing this entire plane. And it's an infinite plane. It goes infinitely down in the negative y direction, infinitely up in the positive y direction, and infinitely in the negative x direction. So something as simple as this inequality, when we graph it, it actually gets an infinite shape, if you will. So it's pretty interesting when we add inequalities to graphs. And we can do the same thing with y. If we use a value of y, the same things will be true. I'll try to get rid of most of that. So let's say y is greater than 1. So when we graph this, again, we want to start with y equals 1 and then figure out which side of the line we're at. So when y equals 1, that's going to be everything above this line. And that's going to be another infinite plane, because any point above this line is going to make this relation, this inequality, true. So it's another infinite plane. It goes on into infinity in 3 of these directions. Let's see. Okay, so now let's do one with both x and y. This is what I wanted to do a little bit earlier, but now that I showed some of those examples, this will make a little bit more sense, I hope. So we're going to make a Cartesian plane, x and y, and we're going to consider the inequality y is less than x. So when y is less than x, whenever we see this inequality, we want to first find what line we're going to be constructing our infinite plane. So first draw the line of y equals x. And that line is going to be, it's going to look something like this. Because no matter where we are on this point, the value of x is going to equal the value of y. And we're saying y is less than x. So to figure out which side of the plane we want to be on, let's just consider a couple values on each side. So here, I didn't draw the tick marks here. 1, 2, 3. 1, 2, 3. I'm not going to draw all of them. But here with the tick marks, let's consider 2 of the tick marks so that this is true. So we're going to say x is greater than y, or y is less than x. So we have to choose two values. So on the x-axis, we have 2. We're going to choose 2 here. And we're going to have x equals 2. And we're going to say that is 2 is going to be greater than 1. So here we're going to choose 1. And when we plot this point, we're going to do 2 over 2 on the x-axis, up 1 on the y-axis. It's going to be here. So this is true, and the point is below this line. So just with one point, we can know that this relation, when graphed, is actually going to be an infinite plane underneath this sloped line. So it doesn't always have to be vertical. And in this one, it's infinite in only 2 directions, actually. It's just infinite in this direction, the x-axis, the positive x-axis, and this direction, and the negative y-axis. So again, another infinite plane. And you can make these more complicated. You could make x squared and have a parabola. You could make the square root of y. You can get creative with it and graph some pretty interesting infinite planes in this manner. Okay, so what else did I want to show? Let's graph an absolute value, because we talked about absolute value in the last video, and I think it's only fair to show you what they look like on a graph as well. So I'm just going to start from scratch with the coordinate system. So again, we have x and y. So let's graph the absolute value of x. We're just going to use an equal sign this time. We did enough inequalities. So we're going to do the absolute value of x equals y. So now let's plug some values in. So we're going to plug in x equals 0. Well, here, I'll make a table. So we're going to have x and y. So when we plug in 0 for x, the absolute value of 0 is just 0. So we're going to get 0 here. When we plug in 1, again, absolute value just takes away the negative. So we're going to get 1 out. And this is going to be the same for any positive number. 2, 2, 3, 3. Where it's going to be different is when we have negative numbers. So let's consider x equals -1. When we put the -1 into the absolute value, we're going to get a +1 out. And it's going to be the same way for every negative number. So we can do -2, -3. Again, plugging those in, we're going to get 2 and 3 out of the equation. Now let's put all these points on this graph. So we have 0, 0, that's just the origin right here. When we plug in 1 for x, we get 1 for y. So it's going to be 1, 1, so it's going to be that point. 2, 2, it's going to be 2, 2, so it's going to be that point. 3, 3, and so on. Now when we go to the negative numbers, so we're going to plug in -1 for x. That is over here. And we're going to get +1 out. So that's actually going to be up here. And then we do the same thing for -2. We take away the negative, and we get a +2 out. So that's going to be here. And -3 and 3 is going to be here. So the plot that we're actually going to get is going to have a corner on it. So it's going to look like that. And if we made this an inequality, we would get a plane. So I'm actually going to make this an inequality now. We're going to do absolute value of x is always greater than y. So if x is always greater than y, we can plug in some values where x does not actually equal y and see what we get. So let's plug in x is 2 and y is 1. So if we plugged in 2 and 1, this would be true because 2 is greater than 1, and we would get a point right here. So we know that this inequality here now represents an infinite plane underneath the absolute values curve. So that's going to be an infinite plane all down here. And it's going to be infinite to the positive x direction, the negative x direction, and the negative y direction. And in some ways you could sort of think of it as eventually approaching infinity in the positive y direction as well, just because it goes up infinitely, but you can't really point the arrow in the same way that you can down here. But I suppose it is infinite in every direction, technically. All right. So now we're going to move on to, what else did I have? Let's see. Okay, well, we did enough with absolute values and inequalities. Let's do distance between 2 points on a line. So I'm going to draw the Cartesian plane again, x and y. I'm going to stop drawing the numbers on the negative side. Just know that if it's on this side, it's going to be negative or negative. So let's consider 2 random points. We're going to do 2, 3. So that's going to be 1 point, 2, 3. And then let's consider 3, 1. So 3, 1. And let's say we want to find the distance between these 2 points. How would we do that? So I want you to think back with the Pythagorean Theorem, or think of the Pythagorean Theorem. You may have heard that word for a bit, but just in case you don't remember it immediately from memory, the Pythagorean Theorem says if you have a right triangle of sides A, B, and C, and again it's a right triangle, it's going to have this property of it. It's going to, if we want to find C and we have A and B, we're going to be able to find it by knowing C squared is always equal to A squared plus B squared. And when we have 2 points like this, we do have a right triangle, and we know the sides, so in that way we can find c squared of the triangle. If you don't see it right away, I'm going to draw the triangle with dotted lines. So this is a right triangle. We know that this, again, from the graph, you can see that this side is of unit 1 because we go from 2 to 3. And then the longer side here is 2 units long because we go from 1 to 3. So we have side A and side B, and we can find C, the distance between these 2 points. So I'm going to do that calculation right now. So we have 2 squared plus 1 squared equals C squared. I'm going to call this C. And we can solve this real quick. So we get 2 squared is 4 plus 1 squared is 1. That's equal to C squared. So we have 5 equals C squared, and C equals the square root of 5. So that's the distance between these 2 points. It's the least amount of distance you would have to travel if you started here and went to here. They're not always nice numbers. I mean, I chose the first example isn't really a nice number, but sometimes it works out to be a really nice number. Okay. And there's an easy way to do this just by knowing the actual points. Because when I was talking about this, how the distance of this side is between 2 and 3, if we look at the actual points here, we see in the x position of these points, we see a 2 and a 3. So really, you can calculate this just by looking at these numbers. So we have side A, again we'll call this A and this B, and keep that as C. So side A is equal to 3 minus 2, and A is in the x direction. Side B is the change in the y direction, which is 3 minus 1, which is 3 minus 1, which is equal to 2. So we got our values of A and B just by looking at the coordinates of the points, and we can solve it. Another way you can write this is just thinking of the change in x and the change in y. So again, in these points, this position represents the x position of the point, and this represents the y position of the point along the y-axis. So you can find the distance between these points by finding distance squared is equal to change in x squared plus change in y squared. So if we actually want the distance c, we just take the square root of both sides. So that's going to be square root of change in x squared plus change in y squared. Okay, what else did I want to do? So yeah, that's the distance between 2 points. Also, you might not always get a value for one of the sides because I chose 2 points that are in different x positions and y positions, but you could have 2 points that are on top of each other. So you could have points like this, both in the point of the graph where x equals 1, so like they're on top of each other, and then in that case you don't really have a triangle, you just have a straight line. So then you could just subtract 3 from 2, and you don't even have to use the Pythagorean theorem. Okay, now let's talk about the slopes of lines, and really the slope-intercept form of a line. So I'm going to erase all of this. We're going to draw up our Cartesian plane again, x and y. And we're going to consider just a normal line, one that doesn't go through the origin. So let's say we have a line like this. Let's say it crosses y equals 3. And let's say it also goes through, well, let's say it has the slope, or a slope of 2. So we're going to say m equals 2. M represents the slope. This line is represented by an equation in slope-intercept form, which is y equals mx plus b. And in this equation, this is always going to be true when m is the slope and b is the point on the y-axis that it crosses. So really it crosses y equals 3, so this is going to be b. So when we plug in m, the slope of the line, and where it crosses the y-axis, 3, into this equation, we're going to get a linear equation that describes this line. And if we wanted to test this, we could plot different values of x, or plug in different values of x, and find out what values of y they are. And we would indeed find that those points that we get out of this equation are all going to fall on this line. So this equation represents an infinite amount of specific points, really a family of points that lie in the real plane on the Cartesian coordinate system. And so this is really easy to go either way. If you have the slope, or you can find the slope and you see where it crosses the y-axis, you can find the equation. Additionally, if you don't have the line and you need to draw the line, but you have the equation, you can draw it real quick just by looking at the slope and the point that it passes. So let's say we have y equals 1/3 x minus 2. So when we look at this equation, we recognize that it is in slope-intercept form, and we can see that whatever is multiplied by the x is going to be the slope. So in this case, it's 1/3. And then whatever is added, again, notice I said added, not subtracted, to this side is going to be the point where it crosses the y-axis. So you can think of this as actually being y equals 1/3 x plus -2. And to graph this real quick, we just look at where it crosses the y-axis. We put a point there, so my marker's dying. So let's say this is -2. So this is the point that it crosses the axis. And then the slope is 1/3. So to draw the slope of the next point, slope, I should also mention slope. So slope is rise over run. So when it's a fraction, we have rise over run. So we're going to go up 1, or rise up 1, and then run over 3. So let's do that on the graph. So 1, 2, 3. So starting from this point, we can start from any point on the line, but this is the only point we know at this point. We're going to draw the next point by moving up 1 and over 3. So that's going to be the next point. And then we could do it again. Up 1, over 3. So 4, 5, 6. And we could go the opposite direction as well. We could go down 1 and then over 3 in the opposite direction. Get a point here. And this is going to be the line it represents. If it was negative, we would go the opposite direction for one of them. And it doesn't matter which one. So let's say it was negative now. And we start from the same point, -2. I really need to get a new marker. Let's try purple. Okay, so we're going to start from this point here. So let's say it's -1/3. So this time we can either go down 1 and over 3, or we could go up 1 and backwards 3. It doesn't matter which way you go, but there we're going to get another line. Again, if the slope was negative. Let's say we wanted to draw a line with the same slope but a different intersection point. So we would just take the new intersection point. So let's say it's not -2 this time. Let's say it's 5 plus 5. And we would do the exact same process. So we would find the point on the y-axis that equals 5. So y equals 5. We'd start there, and then we would just follow the slope and just see where we go next. So here we're going down 1 and over 3. Down 1 and over 3. And we got our new line. So the slope-intercept form is really useful, and it's a very quick way to visualize or just draw out the graph of just a simple line. And let's say you have a question that comes up that says, okay, we have a line, we have the formula, Now, what is the perpendicular line to it? So let's do that right now. Let's say we have this equation here. We're going to get rid of some of these other lines. We have this line, and we want to find the equation for the line that is perpendicular to this line, but still goes through this point 5. It's 5 on the y-axis, so it still goes through this point. So we could draw it. It's going to look something like this. But the easy way to figure out what the equation is by this relation. So we have m1. We're going to call this m1. It's the slope we're starting with. And we want to find the new slope of the line. It's going to have the same intersection point, so we're just going to be changing this. And the new slope of the line is going to be -1 divided by, I should say, we're starting out with m1. We want to find the new slope. The new slope is going to be -1 over m1. So the slope is going to be perpendicular and opposite, so we have to have both the negative and the reciprocal of the original slope. So let's plug this slope in. So we're going to plug m1 in, and we're going to get m2 equals -1 over -1/3. The negatives are going to cancel. So we're going to get m2 equals 1 over 1/3. And since the 3 is in the denominator, inside the denominator, we can move the 3 up to the numerator. Because it's 1 over 1/3, that's just going to equal 3. So the new slope of this line is going to be 3. And the new equation of the line, again, we keep everything else the same with the equation. So we're going to have y equals the new slope, which is 3x plus 5. And this is going to be the equation of this line that is perpendicular to this original line here. Let's see, anything else I wanted to talk about? Okay, well, I hope that makes sense. Yeah, again, if you struggle a little bit with these topics, I would watch the videos maybe once or twice. And if you have any questions, feel free to put them in the comments. I'll do my best to try to respond to them. But there's one more topic that I want to go over before we end this specific series. We'll just get rid of everything and redraw it. So, x and y. So we went over how to draw a graph if you have the slope and the intersection point on the y-axis. And that was y equals mx plus b, where b is the intersection point and m is the slope. Now let's say we want to draw a line with the slope, but instead of the intersection point of the y-axis, we just have a point. Say it's 1, 2. And we want this line to go through this point and have this slope. How do we do that? So to do that, we have a modified version of the Slope-Intercept Form. This, I believe, is called the point-slope form. So instead of y equals mx plus b, we're actually going to have y minus y1 equals m times x minus x1. And y1 is going to be the y in the point. x1 is going to be the x in this point. And we just plug it in and we solve the equation, or we solve the equation and move things around until we get it back into this form, and it's easy to draw again. So again, I'm going to put the point on the graph just so you can visualize it. So the point is 1, 2, so it's 1, 2. That's where we want to start. And we don't know, I guess we have to define m as well. So let's say we want m to equal, say -1. No, we'll say -2. M equals -2. Oh, and I drew a 3. M equals -2. So just from visualizing it, we know that a negative slope is kind of like this. So it's gonna look something like that. But we want to draw it quickly just by solving what the b is and then knowing the slope. We can just connect the lines. So by plugging in y1 and y2 into this equation, we'll get y minus 2 equals negative 2 for m times x minus 1 for x1. Now here I'm going to distribute the 2 to the x and the negative 1, and we're going to get y minus 2 equals negative 2x, and negative times negative is going to be plus 2. And then here we can add 2 to both sides to get y by itself, so plus 2. And we're going to get y equals negative 2x plus 4. And here we found the slope-intercept form starting from a point and a slope. So here now we see the 4 is going to be where it actually intersects the y-axis, if that's going to be up here. And we do have the slope, so we could find more points, but we already have a point that we drew originally from the point that we were given. So really with a line you can just connect them. Oh, that was a terrible line. So we can connect the lines and we get the corresponding line for this equation. We're going to do one more example here before we call it a day. So let's say we have the point negative 1, 4. Let's say we have the slope, let's say m equals, I don't know, let's say 1/5. So I'm going to first draw the point, so negative 1, 4. So we're going to go minus 1 on the x-axis, up 4 on the y-axis. And then we're going to draw write out the the point slope form. So y minus y1 equals m times x minus x1. Again, this is y1, and this is x1. That's a bad y. We'll plug them into the equation, so y minus y1 is 4, equals m, which we were given is 1/5, times x minus x1 is negative 1. And we're going to solve this. So first thing I see is we have two negatives here, so these are going to be positive, and we're going to have y minus 4 equals 1/5 times x plus 1. We're going to distribute the 1/5 to each part of the parentheses that it's multiplying. We're going to get y minus 4 equals 1/5 x plus 1/5. And now we're going to add 4 to both sides. I'm running out of room. Let me erase some of these. I'm going to redraw this at the top. So y minus 4 equals 1/5 x plus 1/5. We're going to add 4 to both sides, so plus 4 plus 4. And we're going to get y equals 1/5 x plus 4 plus 1/5. 4 can be rewritten as 20 over 5. So y equals 1/5 x plus 20 over 5. And if you plug this into a calculator, you'll see that it equals 4, just because 4 5s go into 20. We're going to add this to 1/5, so we have a common denominator, and we can add the top. We're going to get y equals 1/5 x plus 21 over 5. And now we arrived at the point slope form of this line. And now we can draw it relatively easily. So we have the slope, we have the intersection, which is slightly above, slightly above y equals 4. So that's going to be, we'll just say it's right here. And we connect the dots, and this is going to be the line. So that's really all there is to it. You just have to memorize some of these formulas, or even don't even memorize it, just when you need it, just look it up. But that's how you find it. With math, a lot of times you just have to know how to use these equations everybody forgets them at times, but as long as you know how to use it, or you can refresh your memory relatively quickly when you need it, that's really all that matters. All right, that's all I was going to cover for this video. So if you have any comments, feel free to put them in the comments below, and I hope you liked it.